augmentation things. So, but anyway, Dhekane is still an undergraduate student. He did a very great presentation. Okay, please go.
Hello everyone, I'm Sourish Dhekane. I'm a first year PhD student at Georgia Tech, and I'll be presenting our work on finding the minimum pre-training data requirements of self-supervised HAR frameworks. So the application of self-supervised learning for HAR is largely inspired by the lack of labeled data in the community. And the way self-supervised learning addresses this issue is by pre-training the classifiers on a pre-text tasks, and then fine-tuning the same classifier using the available labeled data set. So the standard setup in self-supervised learning is to pre-train the model using a lot of unlabeled data. However, in this work, we are basically interested in asking this question, that are large data amounts really required for effective self-supervised pre-training? So to formalize this question, we formalize it like, what is the minimum amount of unlabeled data that is required for pre-training self-supervised methods, such that the recognition F1 score is within 5% of the same as using the entire data sets. So we perform an empirical evaluation, which is specific to only RIST-1 accelerometer data sets, and we evaluate 3 commonly used self-supervised frameworks, which are CPC, SimClear, and autoencoder, and we evaluate on 3 publicly available datasets, which are HHR, Real World, and PAMAP2. So in our experiments, we first randomly sample k minutes of data from the training set, and then we apply augmentations to generate the pre-training set, which is larger in size. And then we perform pre-training to obtain the model, pre-trained model, which is transferred. And in the fine-tuning step, we use the labels of the same k minutes of randomly sampled data. So those sets are same and kept constant for pre-training as well as fine-tuning. And we start with the value of k, which corresponds to 100% of the data set. And then we slowly decrease this amount to arrive at critical mass. So with 100% of data, if we have Pmax, if we have the performance as Pmax, then we arrive at critical mass, which is basically within the bounds of 5%. So let's look at the results that we have. So these results are for CPC applied on the HHR dataset. It's a plot between the F1 score and the data used in minutes. So we have 3 key findings. The first one is that CPC is the most data efficient, with critical mass just around 9 minutes. So only 9 minutes of data was used for pre-training as well as fine-tuning, which gives you the similar level of performance as using the entire data set. CPC also performs comparable or even better than its supervised counterparts, which basically justifies the choice of using self-supervised learning. And using more pre-training data does not guarantee a better performance. So as we can see here, the peak performance is achieved at around 20 minutes. For SimClear and autoencoders, their critical masses are much larger than CPC, so they are not as data efficient as CPC. However, I'd like to point out that the critical masses are still way lesser than the entire data set amounts, so which is still a noticeable thing. So the key insight gained from this work is that we really don't need that much amount of unlabeled data to pre-train our models. And the reason it's important is that it can lead to a more economical data collection. So let's say if we have a niche HAR problem and we would like to start our data collection, then instead of gathering data for hours and hours, we can just collect a few minutes and still achieve the same level of performance. And we can collect data more smartly in terms of number of participants and which activities to sense and what should be the distribution of those activities. So thank you for listening, and more details and more experiments can be found in our paper. I'd like to take any questions now. Thank you.
Okay, one question, please. Please come. No questions? I cannot see the back side. Okay. Oh, there's one on the back. Thank you.
Thank you for your presentation. I only have one question. Is it just the text data, or you have different types of data you tested with?
Sorry, could you repeat that?
Is it just with text data, or you have a mixture of data that you tested it with?
So in this work, we are using the accelerometer data,
Oh, okay.
not the text one. So,
Okay.
Okay, thank you very much, Sourish.